this has just been set up though through here. Let's see how our graph's getting on. So we've got 6 million have all now been read. So it's now basically sorting. Now you can see things going on in parallel here. You can see 930,000 sorted, 2.7 million, and it's passing the data as far down the pipeline as it can, as quickly as it can. And here we're aggregating. So we're calculating the sum of each order, the amount of discount given, the total number of line items. Then we're counting the count ship period. The one, it's probably easier if I show you with my mouse. This one here is calculating the difference between the date that the first item was shipped and the last. So it's working out the number of days, how slow or fast the order took to ship. It's then sorting that and writing to a file the slowest 100 shipments. So there we are. So that's all run now. And I can, if I look down in the console here, I can see how long that actually took to run. At least I hope it can. 135 seconds. So that's running on a Mac with a fairly juicy processor. I'm not sure, whatever they come with. Not a server. Now let's do the same thing and run it in the cluster that I've just set up. So the first thing I'm going to do is to make sure that my cluster is all up and running. If it's not, I'm going to have to find something else to talk about. It is. So we've now got running clusters. I can also look at the state of my cluster here in the in my cluster monitoring, and you can see we've got 1, 2, 3, 4 cluster nodes up and running. So it's all ready to go now. So how do I actually run this? Well, what I'm going to do is go back again to the designer, and I've actually got one which was set up to run here on the cluster. So it's basically exactly the same transformation, exactly the same quantity of data, but there's a little component here that we use to make sure that the certain things are done when the data is passed out of those parallel processes in the 4 nodes and written out. So I'm not going to go into the detail of that, but it's exactly the same thing that we're running. So I'm now going to run this. Right-click and run the graph. And it'll take, the first time you run it, it's going to take a little bit of time to process, to warm up the server. A few things have to get started. Here we are. It's already at 2 million. So if you remember how long it took on my laptop, it's already at 3.5 million. And I can also go over to the server. Let's go back over to the server and see how things are getting on here. So here's my executions history. And there's this, I can actually expand this. And you can see that is our main process. And these are the 4 nodes, which are shown here as partition workers, which are busily doing their thing, processing the data that's passing through that graph. So I can monitor it in all sorts of different ways. And through here in the GUI, I can also, obviously, I can feed this through event listeners, and you take advantage of all of the other server features. Let me go back, though, to Eclipse, and you can see it's already finished. And if I scroll down, it ran in 32 seconds. So obviously, you can sense or see yourselves just how quickly that actually ran. And I promise you there was no trickery there. That was a genuine run. Now let me go back again into here. So as I said, that test is processing 6 million. So it's not a huge amount of data, and obviously we had to keep it short for the purposes of this presentation. But the benchmarks that we did beforehand on my laptop, well, I put here 150 seconds. It was a bit quicker than that here. With 2 nodes, it was 60, 347, 431, and it can. So effectively, you can see there the near linearity of the scaling, and I think that's pretty impressive. What we were actually doing there in that particular demonstration is we had the 800 megabyte file uploaded into the cluster here. But in many cases, it's not going to be 800 megabytes, it's going to be a terabyte or something big, or there are security considerations why you don't want to or can't put that data up into the cloud. So again, through the flexibility that Clover offers, what you can do is you can point your cluster at a file which is in-house. So let's say you've got an in-house database here in Prague, and your cloud is running on the west coast of the US. You point a component to retrieve data through an FTP connection. And that way you can leave your data where it is. And also, very interestingly, as it starts to read the data in through the top here, and it apportions it amongst all of those, it will do that same kind of multi-threading approach. So it will read data in, and it will start spitting it back out to the other file in Prague as fast as it possibly can. So in many cases, by the time you've finished actually reading in the data from the source, it won't be long. It could be a couple of seconds, and it is already finished writing. So there are all sorts of different configurations. I mean, that you could have that allow you to process the data in the way that you actually need to have your data located or structured. We put together some just some illustrative costs here. So if you imagine that you had a bunch of servers, and it doesn't matter whether it's for Clover or any other application, but if you're going to be running those servers occasionally to do heavy process-intensive jobs, for instance, and the rest of the time it's basically down, this shows the cost savings that you can make. So if that level of utilization is 10%, if you're running it in-house, if you've got, for each in-house server you've got, it's going to cost you around $8,700. That includes the hardware cost, the support and maintenance costs, administrator associated costs, power. We can debate the figure, but it's not a million miles from there. If you're only utilizing them to a level of 10%, you could put it into the cloud and spend $680 on it. So that I think shows very strong. In fact, in the case of Amazon, if you were running it at 100%, if you just left the servers running the whole time, it's still cheaper. So that obviously only works under certain circumstances if you can leave those, if those servers are actually going to be left idle. So in terms of whether your data will scale linearly as you add more nodes into the cluster, David's very nice analogy is it's a bit like if you're digging a ditch, you can use 10 men. They all dig a little bit along the trench and they dig. If you're digging a hole, you can only use one man. The other 9 men will be sitting around watching him dig a hole. So it's it's similar here where we're processing data. Some data isn't nicely parallelizable, but in fact, the majority of data is. So as long as you can get at your data and chunk it, so read chunks out of it, it's going to be very nicely suited to running in a cluster. And in fact, you can achieve even better performance if your application that's generating that data is able to split the data up into separate files. Then it will run even faster. So just to conclude, I think I hope I've shown nicely that Clover starts off at with a desktop designer version, which is very easy, very flexible, very affordable, and then there are lots of stops along the way to ultimately a 50-node cluster. I think probably once you get beyond 50 nodes, you're not going to get huge advantages, but that's an awful lot of processing power by the time you get to 50 nodes in a cluster. We've seen that, I think, demonstrated it delivers scalability, fault tolerance. If you put it into the cloud, a lot of cost advantages. And in 2010, there's obviously, in my relatively brief experience with Clover and Javelin, things have already moved forward nicely. And in 2010, I think there are going to be some pretty exciting things happening as well as we see features being added and generally things being broadened. So thank you all very much for watching. And Martin at the back is the guy who is in charge of it and is the brains behind it. Good job, Martin. So thank you all very much.